Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Patel, and we are going to continue our chapter Velocity and Mechanism, and we are going to study the relative velocity method, and this is our second example of that method, and in this example we are going to solve another little bit complex mechanism. Okay, let's start. You can see the given data on the screen. So angular velocity of crank OA is a 600 RPM. Determine the linear velocity of slider. So slider is there, and we will use our rule number 3 here, which is whenever the slider is given, the velocity of that slider, the line always pass through the origin point. Okay, I will remind the 4 rules of this chapter. First rule is all the fixed point in a space diagram will be at the same point in a velocity diagram. All will be at a origin point, because distance from the origin point indicate the velocity, and so velocity of all the point which have the zero velocity will be at a origin point. Second is a velocity of any point on a link will be perpendicular to the link. So direction will always be the perpendicular to link. Third point is a slider always pass through the origin point, and fourth is for the any point on a link. If you want to find the velocity of any point on a link, you will use the ratio of that space diagram and velocity diagram. Okay, so let's start this. In a second line, angular velocity of link BD when the crank is inclined at an angle of 75 angle is given. As you can see in a figure also, 75 angle is there, and direction of the crank rotation is in an anti-clockwise direction. Okay. So all the lengths of all the link is given. OA is a 28, AB is a 44, BC is a 49, BD is a 46. Center distance between the center of O and C is given 65. The path of travel of the slider is 11 mm below the fixed point C. So you can see the line in which the slider is sliding. The red horizontal line which is passing through the D, and the distance between C. This distance is 11 mm. Okay, we have to draw the space diagram. How you can draw the space diagram? What scale you will take? So largest dimension you can see is a 65 between O and C, and smallest dimension you can see is a 28. So we have to choose the scale here very carefully, because 28 mm. So we can take here 1 gem 1 scale also. Original 28 mm, and largest is a 65, which is very suitable. You can draw it. So let's start. So you will draw this space diagram. So first of all, you have to make the one vertical line here. Length will be 65, because this is the 65 distance between O and C. Okay, and this O point is fixed here, and C point is also here fixed. Now at a 75 angle, okay, you can see the 75 from here, 75. You will draw the O to A, but O to A distance, as you know that distance. So O to A is a 28 mm. So you will draw here 28 mm length, 28, something like this. You will get here the A point. Now you can see on a screen also A to B distances we have and B to C distance we have, but we don't know the angle of that line. So what we will take? We will set that on our compass, and we will take the 2 arcs, and you will get the B distance. Okay, so first of all A to B. So A to B is a 44 and B to C is a 49. So let's set first a 44 here. Okay, and you will make some arc here like this. And after that you will set the 49 and from C to that. So this intersecting point will get here the B point, and you will join this 2 point here like this. Now we need this D point, and how you will get this D point? So you know that from C the line of action of that piston is a 11 mm below. So I will draw here 11 mm and horizontal line here, which is indicating the center line of that piston. We know that from B to D, this BD link, this distance you can see on a screen, this BD link length is a 46. So I will set here 46 like this, and from B to like this, and this point will give me the D point, and I can draw here the one like this. So remember that drawing is this only space diagram is also very important, because the more accuracy you keep here, because we will take the perpendicular from here for velocity diagram, so you will get the correct answer. And this velocity, this space diagram is also very important, because 1 or 2 marks will be given for this space diagram. Okay, so you can see on a screen, this is our space diagram we have getted here. Now you can see for drawing the velocity diagram, you can see on a screen the RPM of this AB link is given. Means this A is rotating in this direction. Okay, so RPM of this crank is rotating like here with respect to O point, and RPM is given. So we can find the linear velocity here. Check this. RPM is given 600 means O. So we will find the omega 2 pi n upon 60. Okay, 2 pi n upon 60. So 2 pi n upon 60, so omega of A with respect to O, you will get 62.84 radian per second. Okay, then you will find the linear velocity of AO is equal to omega AO into length of that link AO. So you will find the velocity of AO here 1.76 meter per. So now how you will draw the velocity diagram here using this velocity. So scale for velocity. What you will take the scale here? You can see the 1.75. So you can take 0.25. If you take 0.25 meter per second is equal to 1 centimeter. So your length of that first vector will be, think about that, 0.25. So our length will be 7 centimeters. So it will be sufficient to draw this diagram. So we can take here 10 mm is equal to 0.25 meter per second. So 1.75. So for 0.25 1 centimeter or 10 mm. So for this our length will be around 7 centimeter or 70 mm. So how you will draw this? Remember that first rule is that all fixed point will be on a origin point. Which are the fixed point? O and C. So O and C, both fixed point will be on a origin point because they are not moving. Some students are confused here. D is fixed. No. You can see on a screen, so whenever in book, sometimes the slider is sliding with respect to this cylinder. This is the slider and this is the cylinder. But in book, what they present like here, like this. They are indicating that this D slider is sliding between these two surfaces. D is not fixed there. It is sliding. Okay. So O and C will be on origin point. Now you will draw the perpendicular to perpendicular to AO here. So perpendicular like this and passing through the origin point. And length will be 7 centimeter. This length will be 7 centimeter. So now I have founded the velocity of A with respect to O. This vector indicating the velocity of A. If you measure, it will give you 7 centimeter or 70 mm. And we know that if you convert using this scale, divide by 0.25, you will get the 1.76. Okay, clear? Now I will find this velocity of B. Because B is connected to A also and B is connected to C also. Because this is a BC link, this is a AB link. So when I am talking about with respect to A, I will take perpendicular like this here. And when I am talking about the C, with respect to C, velocity of B, I will take the perpendicular here. So first of all, with respect to A, okay, so I will set the set square here like this, perpendicular. Right now, I don't know the direction. So I will draw the very light line here because I don't know the length. I know only the direction, which is the perpendicular to link. Like perpendicular, you can use roller here and draw the perpendicular first here and then drag here, and with respect to A you can draw here. Okay, this is also second method. Now with respect to C, you will draw this perpendicular from this BC link. So put the set square here like this and perpendicular to this BC link. But from which point you have to draw? Because right now we are talking about with respect to C, velocity of B with respect to C. So draw line which I want to draw will be passing through the C point. Okay, again. And intersecting point of these two lines will give me this B point. Now very important point, because first time we are going to locate the slider here. Okay. So now D is a slider. Remember that D is equal to slider. And you know that slider, the direction of slider is horizontal, so that is always pass through the origin. So I can draw the horizontal line from our origin point like this. But I don't know the point, where is the D? I don't know. But I know the direction, so I have drawn this dotted line. Okay? But D is also connected to this BD link. And with respect to B, because B we have already found it here, B. So with respect to B, this D will be perpendicular to link. So I will find this perpendicular, means velocity of D with respect to B. So how you can draw this? Like here, put here, perpendicular to this link like here. And intersecting point with that horizontal line will give me the velocity. This point is a D point, which is for the slider. This is a D point. And you can see here, this line, I can say this is the velocity of D with respect to C or O. This line is indicating velocity of D with respect to B. This BA line, if I draw in this direction, I will write here velocity of B with respect to A. Okay. You can see this OB line. What it is indicating, because B is on here, B with respect to A. You can check BA. B with respect to C. So this line will be velocity of B with respect to C. Whatever velocity you want to find, just measure this distance and using this scale you will find the velocity. And sometimes if they say find the angular velocity, you have to divide the linear velocity, divide by the length of that link. Let's check here what they have said, what we have to find here. Determine the velocity of D. Okay, I will measure this OD here, and if I measure this distance here, it is indicating around some 60 mm, and we have taken this scale here 0.25, and I will get this velocity of D with respect to C or O, which is a 1.5 meter per second something. Okay, and other thing they have said, angular velocity of BD. Angular velocity of BD is equal to linear velocity of BD divided by that length BT. Okay, and you will get the answer here. So, angular velocity of BD, if you measure this distance BD here, this B to D, measure that, this is around 70 mm, so you will get here 1.7 meter per second. Okay, and 1.7 divided by this BD distance is given in that, so 0.046, so you will find this angular velocity BD is equal, you will find the omega BD is equal to 36.96 radian per second. Okay.